Hello everyone, today we are going to look at question 4 from the 2011 PAT paper. So, here goes. The figure below shows a rhombus with diagonals A and B, which contains a circle. Find an expression for the ratio of the area of the circle to the area of the rhombus in terms of A and B. Alright, so we've got a circle and we've got a shape, so there are a few things that immediately spring to mind. Let's put them in up here. And one is that the radius of a circle meets a tangent to the circle at 90 degrees. Radius meets tangent at 90 degrees. Okay, so that's one thing we might want to keep in mind. What else have we got? We know the formulas for the area of a circle and the area of a rhombus. Actually, let's define our terms, shall we? So let's say, let r equal the radius of the circle. Let's have AC is the area of the circle. Let's have AR as the area of the rhombus. So what we've been asked to find is the ratio between the area of the circle to the area of the rhombus. So that's going to be AC over AR. And we'll remember to come back to that a little bit later. Alright, what other things might we be thinking about? So we've got radius meets tangent at 90 degrees. Maybe the internal angles sum to 360 of the rhombus, that is. Sum to 360 degrees. I'm just using a little sigma sign there as shorthand for sum because these are just notes to myself. Okay, anything else? Not for now. Let's move on to some of the formulas that we know. So, we know the area of a circle, AC, is pi r squared. We don't know what r is, so that's going to be one thing we'll have to find. We know that the area of a rhombus is the product of the two diagonals divided by 2. So in this case, that is going to be AB over 2. Okay, anything else? Maybe not for now. Let's have another look at this diagram. So what else have we got? We've got, we could mark on a radius here. Let's put this one on here. That's a radius there. So we know the radius of the circle is going to meet the rhombus. And we know actually, we said that a radius meets a tangent at 90 degrees. So we know that actually that's a 90-degree angle there. Okay, so that's interesting because that sets us thinking about some triangles. Because we've got a right angle triangle here. So that would have a base of b over 2. We don't know much about the other things though. But actually we've also got a triangle here. And we know much more about that one. So let's redraw that triangle as a separate little diagram. So it looks like that, and then it's got 2 perpendicular lines there. We know that this length here is going to be a over 2, so let's mark that on our diagram, a over 2. And we know that this length here is b over 2, so let's mark that one on as well. But then we've also got this radius here, and let's put that in. So that is going to go like that, and that will meet this line at r, at 90 degrees. Okay, let's define this length here. Let's call this S. Now, what if we flip this round so that we consider S to be the base of a triangle, and then because R is perpendicular to S, we know that R is the height of our triangle. So maybe I'll just redraw it for simplicity. So if this is S, then off this top left corner we're going to have an a over 2 here. All I'm really doing is rotating this round so that you can definitely see what we're doing here. We've got b over 2, and then we've got r. There we go. Now, the area of a triangle, if you know the height, is straightforward, because the area of a triangle is half times the base times the perpendicular height. So that is going to be half times s times r. Okay, this is interesting, because if we go back to looking at our rhombus, what we've just done is we've worked out the area of this triangle here. Our whole rhombus is just 4 of those triangles. So that means that we've got another expression for the rhombus, for the area of the rhombus. AR is 4 times a half times SR. Remembering S is this length here we've defined. Let's put this on our diagram actually. So this is S here. That one up there. Okay, so we've got 4 times a half SR. So that will give us 2SR. So now what we've got is we've got an expression, we've got 2 expressions for the area of the rhombus. We've got this one, AB over 2, and we've got this one, 2SR. This has got 2 unknowns in it. We don't know S, we don't know R. We probably want R in terms of A and B. So let's see if we can find what S is. Well, we've got a right angle triangle here, so let's just do some Pythagoras on it. S is just the hypotenuse. So S equals the square root of A over 2 squared plus B over 2 squared. Now, if we, let's just multiply this out. So what have we got? We've got a quarter times A squared plus B squared, or a half times the square root of A squared plus B squared. Okay, so we've now got 2 expressions for AR, and we've got them in terms of A, B and R. So we've got that AR equals AB over 2, which also equals 2R times S, which is a half square root of A squared plus B squared. Let's just simplify that a bit. So we have this is R square root of A squared plus B squared. So now we've got an expression for R in terms of A and B. So rearranging, we have that R equals AB divided by 2 times the square root of A squared plus B squared. And that means we can find the area of our circle, because area of a circle is just pi r squared. So area of a circle is pi r squared, which is pi times AB divided by, A squared B squared divided by 4 times A squared plus B squared. And so now we've got our expression for AR, which is AB over 2. We've got our expression for AC, which is this thing here. And finally then, we can do the ratio, which is what it originally asked us for. The ratio of the area of the circle to the area of the rhombus in terms of A and B. So AC over AR. AC over AR equals, so it's pi by 4 A squared B squared divided by A squared plus B squared. And then AR is just AB over 2 from up here. So if we've got AB over 2, we're dividing by AB over 2, which is the same as multiplying by 2 over AB. 2 over AB. Okay, let's just simplify this up then. And what have we got? We've got that this equals pi by 2. Then the a squared b squared will cancel with the ab there. So we get pi by 2 times ab over a squared plus b squared. And that's our answer. So that's a nice nifty way of doing it if you manage to spot this triangle, with this as being the height of the triangle so that you can find the area of it. There are other ways to do this, of course. There is a nice method using similar triangles. See if you can find that. So there's a pair of similar triangles within this shape, if you can spot them. And then you come out with a lot of things that are quite similar. It's a fairly similar method. It's just looking for different combinations of areas. So see if you can come up with that one. But there are going to be lots of different ways of getting to an answer for this one. But that is one of them. So I hope that helps. Next time, we're going to be looking at question 12 on the 2012 paper. So I hope to see you then. Bye, everyone.